Yes, many individuals specify, review, or inspect electrical work using standards from the National Electrical Contractors Association (NECA). These standards are widely used in the electrical industry. NECA provides several key resources, including specifications, inspection services, and installation standards. Firstly, let's discuss NECA specifications. NECA publishes a variety of specifications relevant to electrical installations. A key example is NECA 101, which provides a standard for quality electrical construction. Other specifications include NECA 105 for underground utility installation, NECA 106 for overhead electrical transmission and distribution construction, NECA 110 for industrial electrical systems, and NECA 120 for commercial electrical systems. These specifications are used by architects, engineers, and contractors, ensuring electrical installations meet safety, reliability, and efficiency requirements. Secondly, NECA provides inspection services. NECA offers services to verify if electrical installations comply with NECA standards and other relevant codes and regulations. Building owners, contractors, and insurance companies use these services to confirm electrical systems are safe and meet code requirements. This helps ensure that electrical work has been performed to a known level of quality. Thirdly, installation standards. NECA's installation standards are aligned with the National Electrical Code, NEC, and other applicable codes and regulations. These standards cover a wide range of electrical installation aspects, including wiring methods, overcurrent protection, grounding and bonding, lighting and power distribution, and fire alarm and security systems. By following NECA's installation standards, electrical contractors can ensure that their work meets safety, reliability, and efficiency criteria. There are numerous benefits of using NECA standards. One key benefit is safety. NECA standards are based on the NEC and other pertinent codes and regulations designed to protect people and property from electrical hazards. Using these standards helps minimize risks associated with electrical work. Another benefit is reliability. NECA standards ensure electrical installations are properly designed and installed, which reduces the risk of downtime and costly repairs. This enhances the overall performance and longevity of electrical systems. Efficiency is another advantage. NECA standards promote the use of efficient electrical equipment and practices, which can save energy and money. This is important for sustainable and cost-effective electrical systems. Compliance is also a significant benefit. NECA standards help contractors comply with all applicable codes and regulations, which can avoid costly fines and penalties. Adhering to these standards ensures that electrical work meets legal and regulatory requirements. In conclusion, NECA standards are extensively used by architects, engineers, contractors, and inspectors to ensure that electrical installations are safe, reliable, and efficient. By following NECA's installation standards, contractors can reduce the risk of electrical hazards, downtime, and costly repairs, ultimately contributing to safer and more reliable electrical systems. The National Electrical Code, or NEC, plays a significant role in the development and application of NECA standards. The NEC is a comprehensive set of guidelines and regulations for electrical installations in the United States, and it serves as the foundation for many of NECA's standards. Firstly, scope and purpose of the NEC. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Its primary purpose is to safeguard persons and property from hazards arising from the use of electricity. Secondly, adoption and enforcement. The NEC is adopted by state and local jurisdictions, which then enforce its provisions through inspections and permitting processes. This helps ensure that electrical installations throughout the country meet a minimum level of safety and quality. Thirdly, relationship to NECA standards. NECA standards often reference and expand upon the requirements outlined in the NEC. For example, a NECA standard for commercial electrical systems might provide more detailed guidance on how to implement specific NEC provisions, such as those related to grounding and bonding or overcurrent protection. Furthermore, NECA standards may include best practices and recommendations that go beyond the minimum requirements of the NEC. This can help contractors achieve higher levels of safety, reliability, and efficiency in their electrical installations. The NEC is updated every 3 years through a consensus-based process that involves input from a wide range of stakeholders, including electrical engineers, contractors, manufacturers, and inspectors. This ensures that the code remains current with the latest technologies and best practices. NECA actively participates in the NEC development process, providing technical expertise and advocating for changes that will improve the safety and reliability of electrical installations. NECA provides educational resources and training programs to help contractors and other electrical professionals stay up to date on the latest NEC requirements and best practices. This helps ensure that electrical work is performed safely and in compliance with all applicable codes and regulations. NECA and the NEC work together to promote electrical safety and quality throughout the electrical industry. By following the guidelines and recommendations outlined in these standards, contractors can minimize the risk of electrical hazards, improve the reliability of electrical systems, and ensure compliance with all applicable codes and regulations. In addition to the NEC, other codes and standards may also be relevant to electrical installations depending on the specific application and location. These may include state and local building codes, as well as standards from organizations such as the Institute of Electrical and Electronics Engineers (IEE) and the American National Standards Institute (ANSI). It is important for contractors to be familiar with all of the codes and standards that apply to their work, and to ensure that their electrical installations comply with all applicable requirements. This requires ongoing education and training, as well as a commitment to staying up to date on the latest developments in the electrical industry. NECA plays a key role in providing this education and training and in helping contractors navigate the complex landscape of electrical codes and standards. The installation standards encompass numerous facets of electrical work, ensuring a comprehensive and safe approach. Firstly, wiring methods. This includes selecting the appropriate type of wire or cable for a specific application, as well as the proper techniques for installing and supporting wiring systems. The NEC provides detailed requirements for different wiring methods, such as conduit, cable trays, and directed burial, and NECA standards may offer further guidance on these methods. Secondly, overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow, which can cause overheating and fires. The NEC specifies the required overcurrent protection for different types of circuits and equipment, and NECA standards may provide additional guidance on selecting and installing these devices. Thirdly, grounding and bonding. Grounding and bonding are essential for preventing electrical shock hazards and ensuring the proper operation of electrical equipment. Grounding involves connecting electrical systems and equipment to the earth, while bonding involves connecting different metallic parts of an electrical system together. The NEC provides detailed requirements for grounding and bonding, and NECA standards may offer further guidance on these practices. Fourthly, lighting and power distribution. Lighting and power distribution systems are used to provide electricity to various parts of a building or facility. These systems must be designed and installed to meet the needs of the occupants and to comply with all applicable codes and regulations. NECA standards may provide guidance on designing efficient and reliable lighting and power distribution systems. Fifthly, fire alarm and security systems. Fire alarm and security systems are designed to protect people and property from fire and other hazards. These systems must be installed and maintained in accordance with all applicable codes and standards. NECA standards may provide guidance on installing and testing fire alarm and security systems. Proper grounding and bonding techniques are critical for electrical safety and system performance. Grounding provides a path for fault current to flow back to the source, which helps to trip over current protection devices and prevent electrical shock hazards. Bonding ensures that all metallic parts of an electrical system are at the same electrical potential, which also helps to prevent electrical shock hazards. The NEC provides detailed requirements for grounding and bonding, and NECA standards may offer further guidance on these practices. Some key aspects of grounding and bonding include firstly, grounding electrode system. This is the system of electrodes that are used to connect an electrical system to the earth. The NEC specifies the types of electrodes that are permitted, as well as the requirements for their installation. Secondly, grounding electrode conductor. This is the conductor that connects the grounding electrode system to the electrical system. The NEC specifies the size and type of conductor that must be used. Thirdly, equipment grounding conductor. This is the conductor that connects the non-current carrying metallic parts of electrical equipment to the grounding system. The NEC specifies the size and type of conductor that must be used. Fourthly, bonding jumpers. These are conductors that are used to connect different metallic parts of an electrical system together. The NEC specifies the size and type of conductor that must be used. Proper overcurrent protection is essential for preventing electrical fires and protecting electrical equipment. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The NEC specifies the required overcurrent protection for different types of circuits and equipment, and NECA standards may provide additional guidance on selecting and installing these devices. Some key aspects of overcurrent protection include firstly, circuit breaker selection. Circuit breakers must be selected based on the ampacity of the circuit and the type of equipment being protected. The NEC provides tables and guidelines for selecting the appropriate circuit breaker size. Secondly, fuse selection. Fuses must be selected based on the ampacity of the circuit and the type of equipment being protected. The NEC provides tables and guidelines for selecting the appropriate fuse size. Thirdly, coordination. Overcurrent protection devices must be coordinated to ensure that the device closest to the fault interrupts the current, while devices further upstream remain closed. This helps to minimize the impact of a fault on the electrical system. The selection and installation of wiring methods are critical for ensuring the safety and reliability of electrical systems. The NEC specifies the types of wiring methods that are permitted for different applications, and NECA standards may offer further guidance on these methods. Some common wiring methods include firstly, conduit. Conduit is a rigid or flexible metal or plastic tube that is used to protect and route electrical wires. The NEC specifies the types of conduit that are permitted for different applications, as well as the requirements for its installation. Secondly, cable trays. Cable trays are open support systems that are used to support and route electrical cables. The NEC specifies the types of cable trays that are permitted for different applications, as well as the requirements for their installation. Thirdly, direct burial. Direct burial cables are designed to be buried directly in the earth without any additional protection. The NEC specifies the types of direct burial cables that are permitted, as well as the requirements for their installation. The design and installation of lighting and power distribution systems must comply with all applicable codes and standards. The NEC provides detailed requirements for these systems, and NECA standards may offer further guidance on designing efficient and reliable systems. Some key aspects of lighting and power distribution include firstly, load calculations. Load calculations are used to determine the amount of power that will be required for a particular building or facility. The NEC provides guidelines for performing load calculations. Secondly, panel board selection. Panel boards are used to distribute power to different circuits within a building. The NEC specifies the requirements for panel board selection and installation. Thirdly, branch circuit design. Branch circuits are the circuits that supply power to individual outlets and equipment. The NEC specifies the requirements for branch circuit design. Fire alarm and security systems must be installed and maintained in accordance with all applicable codes and standards. The National Fire Protection Association (NFPA) provides detailed standards for these systems, and NECA standards may offer further guidance on installing and testing them. Some key aspects of fire alarm and security systems include firstly, system design. Fire alarm and security systems must be designed to meet the specific needs of the building or facility being protected. The NFPA provides guidelines for system design. Secondly, installation. Fire alarm and security systems must be installed in accordance with all applicable codes and standards. The NFPA provides guidelines for installation. Thirdly, testing and maintenance. Fire alarm and security systems must be tested and maintained regularly to ensure that they are functioning properly. The NFPA provides guidelines for testing and maintenance. The NECA has tables that are essential resources for electrical installations. These tables provide detailed information on a wide range of topics, including wire ampacity, conduit fill, and overcurrent protection. Some key NECA tables include, firstly, Table 310.15b16. This table provides the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air. Secondly, Table 310.15b17. This table provides the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in raceway or cable. Thirdly, Table 310.16. This table provides the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, not more than 3 current-carrying conductors in raceway or cable or earth directly buried, based on ambient temperature of 30 degrees Celsius. Fourthly, Table 310.15b3. Adjustment factors for more than 3 current-carrying conductors in a raceway or cable. These tables are essential for selecting the appropriate wire size and overcurrent protection for electrical circuits. For example, if a circuit is designed to carry 20 amps, the wire must be sized to handle that current without overheating. Table 310.16 can be used to determine the minimum wire size required for a 20 amp circuit based on the type of insulation and the ambient temperature. The National Electrical Codes Chapter 9 contains several informative tables that are essential for electrical calculations and installations. These tables provide data on conduit and tubing fill, conductor properties, and other important factors. Firstly, Table 1 lists the percent of cross-section of conduit and tubing for conductors. This table is used to determine the maximum number of conductors that can be installed in a specific size of conduit or tubing. Secondly, Table 4 provides the dimensions and percent area of conduit and tubing. This table is used to determine the size of conduit or tubing required for a specific number of conductors. Thirdly, Table 5 lists the dimensions of insulated conductors and fixture wires. This table is used to determine the space required for conductors and conduit or tubing. Fourthly, Table 8 provides the properties of conductors, including their DC resistance and reactance. This table is used for voltage drop calculations. Fifthly, Table 9 provides the AC resistance and reactance for 600-volt cables, 3 single conductors in a raceway. This table is also used for voltage drop calculations, specifically for alternating current systems. Understanding and using these tables correctly is crucial for ensuring that electrical installations comply with the NECA and are safe and reliable. They are used in conjunction with other sections of the code to perform calculations and make informed decisions about conductor sizing, conduit selection, and other aspects of electrical design and installation. The importance of safety cannot be overstated in electrical installations. Electrical hazards can cause serious injury or death, as well as property damage. By following NECA standards and adhering to the NECA, contractors can minimize the risk of electrical accidents and create safer environments for workers and the public. Some key safety practices include, firstly, de-energizing circuits before working on them. This is the most important safety practice. Always verify that the circuit is de-energized using a voltage tester before touching any wires or equipment. Secondly, using appropriate personal protective equipment (PPE). This includes items such as safety glasses, gloves, and insulated tools. Thirdly, following lockout/tagout procedures. These procedures are used to ensure that circuits remain de-energized while work is being performed. Fourthly, being aware of potential hazards. This includes things such as overhead power lines, underground utilities, and energized equipment. Fifthly, never working alone. Always have another person present who can provide assistance in case of an emergency. Regular inspections are essential for ensuring that electrical installations are safe and compliant. Inspections can help to identify potential hazards and code violations before they cause problems. NECA offers inspection services to verify that electrical installations comply with NECA standards and other applicable codes and regulations. These services can be used by building owners, contractors, and insurance companies to ensure that electrical systems are safe and up to code. The benefits of using NECA standards for electrical installations are numerous. These standards provide a framework for ensuring that electrical work is performed safely, reliably, and efficiently. By following NECA standards, contractors can minimize the risk of electrical accidents, improve the performance of electrical systems, and comply with all applicable codes and regulations. In addition to the benefits already mentioned, NECA standards can also help contractors to improve their business practices and increase their profitability. By following these standards, contractors can reduce the risk of rework and callbacks, improve their efficiency, and enhance their reputation for quality. Overall, NECA standards are a valuable resource for anyone involved in electrical installations. By following these standards, contractors can ensure that their work is safe, reliable, and compliant, and they can also improve their business practices and increase their profitability. The NECA serves as the cornerstone for electrical safety and provides requirements for electrical installations. NECA standards often expand upon these requirements and provide more specific guidance for contractors. Firstly, the NECA is updated every 3 years. This ensures that the code remains current with the latest technologies and best practices. Secondly, the NECA is adopted by state and local jurisdictions. This means that it has the force of law and must be followed by all electrical contractors. Thirdly, the NECA is a consensus-based code. This means that it is developed through a process that involves input from a wide range of stakeholders, including electrical engineers, contractors, manufacturers, and inspectors. NECA actively participates in the NECA development process. This helps to ensure that the code reflects the needs of the electrical industry and promotes safety and quality. NECA standards often reference and expand upon the requirements outlined in the NECA. For example, a NECA standard for commercial electrical systems might provide more detailed guidance on how to implement specific NECA provisions, such as those related to grounding and bonding or overcurrent protection. NECA provides educational resources and training programs to help contractors and other electrical professionals stay up to date on the latest NECA requirements and best practices. This helps ensure that electrical work is performed safely and in compliance with all applicable codes and regulations. The combination of the NECA and NECA standards provides a comprehensive framework for ensuring electrical safety and quality. Contractors who follow these guidelines can minimize the risk of electrical hazards, improve the reliability of electrical systems, and comply with all applicable codes and regulations.